Every night, one of the brightest stars in Earth's sky moves a little closer to the end of its life. That star is Betelgeuse, the enormous red supergiant marking Orion's shoulder. It's so large that if it replaced our Sun, its outer atmosphere would extend beyond the orbit of Jupiter. Astronomers know it will eventually explode as a supernova, but no one knows exactly when. It could happen thousands of years from now, or because its light takes about 550 years to reach us, it may have already exploded, and we simply haven't seen it yet. But what exactly is Betelgeuse? Why has it become one of the most unpredictable stars in our galaxy? And if it exploded tomorrow, what would people on Earth actually see? Let's find out. Betelgeuse is located about 550 light-years from Earth, close enough for astronomers to study in remarkable detail. In fact, it was the first star beyond our solar system whose surface was ever measured, something once thought impossible. Over the decades, powerful telescopes have revealed that Betelgeuse is far from a perfect sphere. Its surface constantly shifts and changes shape, while enormous plumes of gas erupt into space before cooling into clouds of dust that surround the star. These outbursts are only possible because Betelgeuse has reached an advanced stage of its evolution. Deep inside, the simple hydrogen fusion that powers stars like our Sun is largely over. Instead, the star is fusing progressively heavier elements in a series of increasingly unstable reactions. Each new stage lasts less time than the one before, bringing Betelgeuse one step closer to the moment its core can no longer support its own weight. One of the biggest challenges for astronomers has been figuring out just how large the star really is. Unlike the Sun, Betelgeuse doesn't have a sharp, well-defined edge. Its outer layers are diffuse and constantly expanding, making different measurements produce slightly different results. Current estimates place its radius between 640 and 760 times that of the Sun. If it occupied the center of our solar system, its visible surface would reach roughly to Jupiter's orbit, while its extended atmosphere would stretch even farther. In late 2019, Betelgeuse did something no one expected. One of the brightest stars in the night sky began fading at an astonishing rate. Within just a few months, its brightness dropped by nearly 2/3, falling from magnitude 0.5 to a record low of about 1.6. For the first time in modern history, Betelgeuse slipped out of the list of the 10 brightest stars visible from Earth. The sudden change sparked headlines around the world. Many wondered whether the giant star was finally about to explode as a supernova. Astronomers, however, urged caution. While Betelgeuse is destined to end its life in a colossal explosion, current models still place that event somewhere within the next 100,000 years, making an imminent supernova extremely unlikely. So, what actually happened? The answer began to emerge after months of observations by the Hubble Space Telescope and other observatories. Researchers found evidence that Betelgeuse had blasted an enormous cloud of superheated gas from its surface. As the material traveled away from the star, it cooled and condensed into dust. That dust drifted in front of part of Betelgeuse, temporarily blocking a significant portion of its light from reaching Earth. The event was unlike the star's normal pulsations, although astronomers believe those regular brightness cycles may have amplified the effect. Some studies also suggest that a giant cool region on the star's surface contributed to the dramatic fade. By early 2020, Betelgeuse slowly began to brighten again, and by 2023, it had largely returned to its usual brilliance. Instead of witnessing the birth of a supernova, astronomers had captured something almost as remarkable: a rare, real-time look at a red supergiant violently shedding material into space. You might think measuring the size of a star is as simple as measuring the size of a planet. For Betelgeuse, it's anything but. In 1920, it became the first star beyond our solar system, whose apparent disk was successfully measured, a milestone that transformed stellar astronomy. But more than a century later, astronomers are still debating its exact size. The problem is that Betelgeuse doesn't have a well-defined surface. Instead, its outer layers gradually fade into space, making it impossible to point to a single, precise edge. The answer also depends on how you look at it. Visible light, infrared, and radio observations each reveal different layers of the star, meaning every telescope is effectively measuring something slightly different. That complexity even led to one of Betelgeuse's biggest mysteries. Between 1993 and 2009, observations suggested the star had shrunk by roughly 15%. It was an astonishing claim. Had one of the largest known stars somehow begun collapsing? As better observations became available, astronomers reached a different conclusion. The apparent change wasn't caused by the star itself rapidly shrinking. Instead, it was the result of its restless outer atmosphere, where constantly shifting gas and dust can make Betelgeuse appear larger or smaller over time. For a star that has been studied for centuries, Betelgeuse still refuses to give astronomers an easy answer, even to one of the simplest questions: how big is it? Although Betelgeuse still shines brilliantly in our sky, its core tells a very different story. Stars spend most of their lives fusing hydrogen into helium, but Betelgeuse exhausted the hydrogen in its core long ago. As gravity compressed the core, temperatures climbed to around 100 million degrees Celsius, 180 million degrees Fahrenheit, hot enough to ignite helium fusion. That stage produced heavier elements including carbon and oxygen. Today, astronomers believe Betelgeuse has advanced even further. While its exact evolutionary stage remains uncertain, current stellar models suggest it's likely burning carbon in its core, or has already moved beyond that phase, with multiple shells of fusion operating simultaneously. Instead of one central furnace like the Sun, Betelgeuse has become layered like an onion, with different elements fusing at different depths. The pace of this evolution is astonishing. Hydrogen fusion kept the star alive for millions of years. Helium burning lasted only a few 100,000 years. Carbon burning is expected to continue for only a few hundred to a few thousand years. The final stages accelerate dramatically. Neon burning may last about a year, oxygen burning just a few months, and silicon burning only a day or two before the star reaches the end. That final stage creates an iron core, roughly comparable in size to Earth, but containing well over 1 solar mass. Iron is the dead end of nuclear fusion. It consumes energy instead of releasing it. Once enough iron accumulates, the outward pressure supporting the star suddenly disappears. Gravity takes over, and in less than 1 second, the core collapses inward at a significant fraction of the speed of light, triggering the supernova that will ultimately destroy the star. Exactly when Betelgeuse will reach that point remains one of astronomy's biggest unanswered questions. When Betelgeuse finally dies, it won't simply vanish. In a fraction of a second, its core will collapse from a sphere roughly the size of Earth to an object only about 20 kilometers, 12 miles across, if it forms a neutron star. Temperatures will soar into the hundreds of billions of degrees, and an immense flood of neutrinos will carry away most of the collapsing core's energy. The collapse produces a powerful shock wave that races outward through the star. As it reaches the surface, Betelgeuse will explode as a Type II supernova, blasting its outer layers into space at speeds of 10,000 to 30,000 kilometers per second, 22 to 67 million miles per hour. The explosion will forge and scatter many of the heavy elements that make rocky planets, and even life, possible. Elements such as calcium, silicon, and iron will be hurled across interstellar space, eventually becoming part of future generations of stars and planets. The expanding debris won't disappear quickly. Over thousands of years, it will create a glowing supernova remnant stretching across light years of space. At its center, astronomers expect either a neutron star or, if the remaining core proves massive enough, a black hole. Current models slightly favor the neutron star outcome, but the final result cannot yet be predicted with certainty because it depends on how much mass Betelgeuse loses before it explodes. If Betelgeuse exploded tomorrow, Earth would witness one of the greatest astronomical events in recorded history. Although the explosion would occur about 550 light-years away, it would become visible almost immediately after its light reached us. For weeks, the supernova could rival the brightness of the half-moon, making it clearly visible even during the daytime. At night, it would cast faint shadows and completely transform the familiar outline of Orion. The brilliant display wouldn't last for just a single night. Betelgeuse would remain exceptionally bright for several months before gradually fading over the following year. For generations, people would remember exactly where they were when a new star suddenly appeared in the sky. Despite its spectacular appearance, Earth would remain safe. Studies show a supernova would need to occur within roughly 30 to 50 light-years to pose a serious threat to our planet through intense radiation. Betelgeuse is more than 10 times farther away. The event would also become one of the greatest scientific opportunities in history. Every major observatory on Earth and in space would turn toward Orion, allowing astronomers to study a nearby supernova in unprecedented detail, something humanity has never been able to do with modern instruments. The first sign of Betelgeuse's death wouldn't be visible at all. When the core collapses, it releases an enormous burst of neutrinos, tiny particles that interact so weakly with matter that trillions pass through your body every second without leaving a trace. During a supernova, however, the numbers become almost unimaginable. In just a few seconds, Betelgeuse would release more energy in neutrinos than the Sun will emit in light over its entire 10 billion year lifetime. Because neutrinos escape the collapsing core almost immediately, they would reach Earth hours before the first visible light from the explosion. Underground detectors such as Super Kamiokande in Japan, IceCube at the South Pole, and other observatories would register an enormous spike almost simultaneously. Astronomers would instantly recognize the signal. Long before anyone looked up and saw a new blazing object in Orion, observatories around the world would receive an automated alert announcing that a nearby star had just exploded. Humanity would have a rare countdown. For perhaps several hours, scientists would know a supernova was on its way before the sky itself revealed the event. No civilization in history has ever experienced such an advance warning of a nearby stellar explosion. Once the light fades, Betelgeuse won't disappear completely. Its core will survive in one of the most extreme forms known in the universe. If the remaining core is light enough, gravity will compress it into a neutron star, an object only about 20 kilometers across, but containing roughly 1.4 to 2 times the Sun's mass. A single teaspoon of neutron star material would weigh billions of tons on Earth. If the core is more massive than current models allow a neutron star to support, gravity will continue crushing it until a black hole forms. At that point, not even light can escape. Which outcome awaits Betelgeuse is still uncertain. The answer depends largely on how much mass the star loses before the explosion, and Betelgeuse has been shedding enormous amounts of gas and dust for thousands of years. That ongoing mass loss makes predicting its final fate surprisingly difficult. Whatever remains, the surrounding cloud of expanding debris will continue enriching the Milky Way with newly forged heavy elements. Billions of years from now, some of those atoms may become part of new stars, new planets, and perhaps even new forms of life. In that sense, Betelgeuse's death won't simply mark the end of a star. It will also become the beginning of something entirely new.